Well, good morning. Let's talk equivalent ratios. We've kind of done some work like this in the past, so hopefully this won't be too bad. We need to decide if any of these groups of ratios, A, B, C, D, are equivalent to each other. Well, how do we do that? Well, you look for a common factor that you multiply or divide each side of the ratio by. So let's look. How would I get from 1 to 5 using multiplication or division? Oh, 1 times 5. Okay. So if I try to do this side times 5, what do I get? 2 times 5, is actually 10. So A equals B. Let's try down here to 6. 1 times 6 gets me to 6. Okay, so 2 times 6 is 12. Ooh, that's not a 12. All right, 1 times 12 is 12. 2 times 12 is 24. Oh, doesn't work there. We know B already equals A, and we know that A doesn't equal either of these. Therefore, B cannot either, because B is equal to A. So if A doesn't work, B is not going to work. So let's check C. We only have to check to see if C equals D. How do I get from 6 to 12? 6 times 2. 6 times 2 is 12. What's 16 times 2? Oh, 32. Okay. Let's see. How could we write the value of the ratio? So this is new. Value of the ratio, ratio is really equal to simplify it. Okay, simplify your ratio. So 1 to 2. 1 is prime, 2 is prime. This is the simplest. So its value is 1 to 2. Now 5 and 10 share a factor of 5, and 5 divided by 5 is 1, and 10 divided by 5 is 2. So its value is also 1 to 2, which is a sort of a big deal because if A equals B, their values should be the same. And that's another way you can tell if ratios are equivalent. If they have the same value, they must be equivalent. 6 and 16 share 2 as a factor. So if we divide 6 by 2, we get 3, and 16 by 2, we get 8. 3 is prime and does not go into 8, so we are done simplifying that. And because these are equal, that one must also be 3 to 8. Okay, that's how you find the value. All right, let's see. Tavon is training for a duathlon. Okay. Tavon is training for a duathlon, which is a race that consists of running and cycling. The cycling leg is longer than the running leg, so that if he rides his bike more than he runs. Okay, cycling, running. During training, Tavon runs 4 miles, and cycles 14. What's the value of this ratio? Oh, value. Simplify. Any common factors? Okay, so the factors of 4, just because it's smaller, are 1 times 4. 4 doesn't go into 14. And 2 times 2. 2 goes into 14. So if I divide both of them by 2, then I would get 7 to 2. Okay, let's see what the questions are. Identify the ratio with the problem. Check, did that. When Tavon completed all his training for the duathlon, the ratio of the total number of miles he ran to the total number of miles he cycled was 80 to 280. So ran 80, cycled 280. Is this consistent with his training schedule? Meaning, is the value of this ratio the same? This might take a little longer because they're bigger numbers, and I don't expect you to know the greatest common factor of those big numbers, but we should be able to first see that they have zeros on the end, which means we can divide by 10. So then we end up with 28 to 8. Okay. Yes, we can divide by 2, but is there anything bigger? So the factors of 8 are 1 times 8. 8 does not go into 28. 8 times 3 is 24. 8 times 4 is 32. And then we have 2 times 4. Let's try the 4. 4 goes into 8. 4 goes into 28. So we can divide both by 4. 28 divided by 4 is 7. 8 divided by 4 is 2. Are their values the same? Yes. That means Tavon did follow his schedule because his 280 miles to 80 miles matches this value. That means he was following his training schedule. In one training session, Tavon ran 4 miles and cycled 7 miles. Did this match his training schedule? So does this match 7 to 2? Well, can this be reduced at all? Let's stick with the 4 because we've talked about that one. 1 and 4. 4 doesn't go into 7. 2 times 2. 2 doesn't go into 7. That means this is simplified. The value of this ratio is 7 to 4. Does this value match the other two? Nope. This did not follow. Okay? All right. That should get you enough to be able to do your assignment. Good luck.